All right, good morning. Looks like we're ready to get started. Oops, I think maybe, is there an echo? Yep, okay, let me mute that. Should be good now. So here we go, right? We don't have a ton of time left in the class. We're kind of wrapping things up here. I'm going to talk more about hypothesis tests today. Let's just take a look at the calendar here. We've got the instructional calendar. So we've got what? Thanksgiving is tomorrow. Then we come back we're Monday, Wednesday. So we'll come back and have 4 more class visits. I think we'll more or less probably be done with hypothesis testing today. Might spill over into next time. But that means that at that point, the class meetings really will be focused on the project. I'll talk about the project. You should bring me questions for the project, right? I know that attendance, because I post these videos and the people are watching them later, there's less people showing up to the actual meetings, and some people have to do that for different reasons. I would say for those last 4 weeks, probably show up, because watching the videos at a later date may not be as helpful because I don't have as much to go over with you. I'm going to talk about stuff and guide you through it. And we do have one day that we have to devote to a special topic, as I'll explain when we get back. That I need is actually a school requirement. It has to do with accreditation. We have to give a special quiz that the class has to take, and we have to be able to show that as evidence that people are learning. But that's another topic we'll deal with on a specific day. Otherwise, I'm largely going to be answering questions and explaining things about the project. So any kind of questions or concerns you have, that will be the time to talk about it. After we come back from Thanksgiving is when we will address those issues. Okay? The day that the projects are due or the night before the projects are due, I'm going to get emails of people saying like, okay, so what am I supposed to do in the project? What do you want me to do in the project? Like, that's too late. If you're coming to me with questions, and you shouldn't be asking those kinds of questions anyways, because then it would be clear you haven't really done anything. But if you come to me, during these class meetings and you're like, I'm just having trouble with the, confidence intervals for the proportion, and this is what I've done. Am I doing this wrong? Is this what you want to see? And then we can talk about it, right? There has to be have been some effort on your part in order to start to put things together. You can't just come in and say, I don't get hypothesis testing. Well, we talked about it for numerous days. I can't just sum it up in 5 minutes and have it make sense to you, right? So you'll have to do some work on your part. That's exactly the kind of stuff you should be doing in your groups, getting together in groups, share with each other what you're each doing for your project. I'm not saying like do other people's work for them, but you could all bring your histograms together and compare histograms and go, wow, yours looks really good. What did you do here? Right? And then that's actually a learning process for all of you, and you'll all get better, right? You don't have to support someone in your group that you don't think is working very hard. But, usually most of the time in these groups, everyone's pitching in, or almost everybody is pitching in, and then people are pretty happy to share with each other, right? If you know that person across the desk from you put in the effort, usually people are like, yeah, I'll show you what I did and show me what you did, and we'll kind of compare. But again, you're all doing your own project, so you don't have to share anything with anybody. But it's usually both people benefit. Like I say, unless you have someone who's just showing up and they're like, histogram, what is that again? I didn't make any histograms. Is that the one with the bars in it? Fine. Then, if you don't want to help that person out, you don't have to. But I do find generally that when there's 2 people participating in the class and they sit down and they're like, well, here's what I made. The other person says, here's what I made. And you look at each other, you're both probably a little more confident after that meeting than you were before it. So it's mutually beneficial, right? Both people end up doing well. And maybe you're in a group where everyone's working really hard. That's the best, right? That's when I see people really do well with stuff. So keep that up. When we come back, we have to revisit correlation and regression. So would be good maybe if you worked on that part of your project a little bit. So you just be a little more familiar with it, because you're going to have to take a quiz on it. That ends up being part of your grade. This is actually school mandated for in each class. We have a particular quiz that we have to give. It's part of accreditation. So if you if you're comfortable with regression and linear correlation and all that kind of stuff, then it shouldn't be very hard for you. But we're going to have to spend a day going over that after the break. And then we'll move forward with the course. Okay, so where am I? Week 15. So we're a little bit ahead, and I did that on purpose. Most of you are probably working on homework for confidence intervals, right? And then, some of you have started hypothesis testing. Some of you are not quite there yet. That's fine. That's okay. It's not due yet. But I need to talk about it early because it's not one of those topics that I can teach you the day before the deadline and you're like, yeah, I get it. Like, hypothesis tests take a while to get through. Please don't wait till December 7th to do this stuff. That's one of the last regular days. That's right before finals hit. You should be doing this ahead of time. I've put that in there to help out people who have to get it done at the last minute for whatever reason. You're all going to have stuff going on, right? Probably going to have a couple people sick after Thanksgiving, right? The bump is already occurring in cases, and it's only going to get worse when everyone gets together in a house with 20, 30 people in it, and people are going to spread stuff to each other. So stuff's going to happen, right? But if you're learning hypothesis tests on December 7th, that means that you're not really doing a good job on hypothesis tests in your project. Why? Well, how do I know that? Well, because you haven't learned the material. How can you be preparing a good hypothesis test for your project if you haven't learned the material yet, right? It's becoming more and more of a sort of a cultural thing. Cultural as in American culture, like in this country, by and large, that we wait till the last minute. If something says December 7th, that means I'm going to do it December 7th, right? And that is that's the wrong strategy as a student. If you really want to do well as a student, you should be doing things before they're due, right? I can tell you there's generally a big difference between when students turn assignments in a couple days ahead of time, I look at it, it's almost always very excellent work, right? The stuff that's turned in 3 minutes before the due date, usually not as good a quality because those people were trying to get it done at the end and they're like, okay, I'm gonna it's due December 7th at midnight. All right, I'll start it at 9. And then, they're rushing through it and they're just trying to get points, not really focused on the learning. So I would encourage you, don't sit on this chapter. Don't wait. Try, if you can get it done at the beginning of December, then do that, because that means you can start working on the hypothesis portion of your project and getting all that work done, and it's just going to work that much better because the whole reason we do the project is you learn stuff as you move through it. Just like the questions for the project, we covered asking questions in class, and this happens even when we're in the classroom, where we'll spend a day talking about asking good questions, and students go, okay, yeah, I get what you're saying. But then when we actually have to write questions for the survey, students struggle with it, right? Even the questions that we got, really, some of them weren't worded great. Some of them were great. Some of them worded, this could be better, right? And then some of them, we always get a few questions that are just written terribly, unusably, but that's part of that learning process, right? In reality, there's this view of education that you learn things by watching other people do stuff. You don't. Watching other people do stuff can be helpful to get you started, but if you haven't done it yourself, you haven't done anything, right? Really. So, watching some videos on how to do hypothesis tests is fine, but until you have actually run some hypothesis tests, till you have done the numbers, then you don't know how to do a hypothesis test, right? You don't really know what it means, because it's another thing when you get in there and go, oh, this is kind of harder than I thought. And that's one of the number one things we hear as a math teacher, which is students will come to us and say, well, I understood it when you were doing it. Well, right. Anything's easy if I'm doing it. And you're just sitting in a chair pointing your eyes in my direction, then it's easy to watch me do anything, right? It's when, the effort gets handed over to you and said, no, now it's your turn, then it's hard, right? So it's that mindset that watching someone do something is learning It isn't. You learn it when you do it for yourself. So bottom line, don't wait till December 7th. If you do, you're setting yourself up just to not do as well on that part of the project. And then also, my students get super stressed out and asking for extensions. There can be no extensions on these because that's the end of regular semester. And then we enter finals week. And I have to start right at the beginning of finals week. I have to start prepping all my grades so that as soon as I can, I got to turn in those final grades for the course, right? Administration is on our case. Students want the grades turned in. It's a good idea to turn them in. Once I get them turned in, I'm done for the semester. So sort of 100% of us want me to get those grades in fast, right? Because you need to send out your transcripts to other schools, and your financial aid wants to know how you did in the classes they paid for and stuff like that. So literally within a day or two of us, in fact, we get one right at the beginning of finals week. We start getting these emails that are like, okay, get your grades turned in. Why aren't your grades turned in? Turn your grades in. And so we gotta get them turned in. And I'm talking about emails from administration. Like they want the grades in. Students want the grades in. Because, and I get those emails too, where a student is like, I got to get my transcript over to, UCSB. Can you get those grades turned in? They're waiting on me to accept me over there till I turn this transcript in. So there's a lot of pressure to get grades turned in fast. There's no time for messing around. So just make sure that when you turn in your video, you've done it well. You can turn the video in early. That's great. I'll actually watch it early because I've got, somewhere in the neighborhood of potentially up to 120, but probably under 100 videos to watch. That's going to take me a while if you think about it. So I'll start watching them early, and if I see a problem like I can't open your file, I'll shoot you an email, and maybe in the next day you can get it posted correctly or something. But there's really no time for being late with this kind of stuff. So basically, don't procrastinate. Just get in there and get it done. Okay, with that said, let's see, I think that's all of that. Let's jump over to here. Let's move this. So, I'm not covering every detail of hypothesis tests because you still have to go through and do the lessons for hypothesis testing. That's where you should be learning the details of the calculations, right? So you're actually going to do some problems in the homework using hypothesis tests. Remember, there's those buttons in there that say I forget what it says, if it says technical help or something like that, but those buttons are helpful. Explore all three of those buttons if you're getting stuck. One of them shows you what buttons you're supposed to push in StatCrunch. So if you forget how to do a thing in StatCrunch, remember, they've got it in there, written in there. You press that button and it shows you how to do the StatCrunch steps, okay? So you should be able to go and do that. What I'm trying to cover here is the details that I see students just not get. They don't understand, or they memorize how to run a hypothesis test, and they can tell me if they rejected the null or not, usually correctly, but they have no idea what it means or why the system works the way it does. And then that often leads to your final conclusion being wrong, where someone will say something like, oh yeah, we just proved the thing that was our null hypothesis, or we accept the null hypothesis, or something like that, which is just mathematically incorrect. It's not that I'm being, trying to be super strict about the language. It's that it is mathematically wrong. The way the probabilities play out and the logic of a hypothesis test, you cannot prove the null hypothesis. The only thing that you can gain evidence for that you want to prove something or show strong evidence for is the alternative hypothesis. So if the thing that you want to show evidence for, you have a statement and you want to be able to say, we think that the mean number of units that a student takes during the COVID period is more than 8 units, right? Well, you could run a hypothesis test on that, and if that's what you're trying to prove, that needs to be your alternative hypothesis. And then your hope is that you can reject the null hypothesis, because you can either reject the null or fail to reject the null, but you can't accept the null. You can't say, yep, we got a high probability. That just shows that the null is true. It doesn't show the null is true. It shows that the null is plausible, right? Everyone know what the word plausible means? Anybody ever watch Mythbusters, right? So plausible doesn't mean that they proved that this urban myth occurred. It means that it's reasonable that it could have happened this way. But when they run their experiments on Mythbusters, they don't prove that a certain thing happened, right? Like when they do their thing where they make a boat just out of duct tape to see if that was a possible way of escaping a prison, that doesn't prove that someone actually used a duct tape boat to escape from prison. What they show is it's possible someone could have done it if they were, if they did it the right way, it could be done. But that doesn't prove that someone actually did it, right? That's why they say plausible on that show. They don't ever say like we proved this urban myth. They're because you don't really know if it happened or not. What they can prove is, it's possible that this thing occurred the way that is being described. It's plausible. That's kind of the same thing here. If you get a high p-value, that just means that your null hypothesis is plausible. It's possible that it happened that way, and it's reasonable to think that it may have happened that way. But it doesn't prove that it did, okay? What happens the other way, if your p-value is so incredibly low that we're like, I just can't believe that. The one time we did this, we get an outcome that only happens is only expected to happen once every 1,000 times. That's pretty unlikely, right? So then you can reject the null, and then that gives evidence for the alternative. That's how you gain evidence for the thing you want to prove, is you make it the alternative, and you hopefully reject the null. Otherwise, you're going to be disappointed. You don't really get a choice in the p-value. And the p-value is the probability of getting an outcome like you got or more extreme, right? So if you get a certain outcome and that probability is tiny, 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 then what that probably means is that your assumption that you made, which is your hypothesis, is wrong. So then you reject it. Well, if you reject the null hypothesis, then the other thing that's left is the alternative hypothesis, and you've just gained evidence for that. So I know it sounds like, and I get it, it's weird for students when you first are exposed to this. It kind of seems like, well, I still don't get why I can't prove the null. But it's kind of comes down to that discussion of plausibility. You can show that it's plausible that a thing occurred, but that doesn't mean that is what occurred. Okay, there's just the probabilities don't work that way in a hypothesis test. So I'm not really a big fan of these things, but if it helps you as a student, go for it. Like, don't feel bad if you have to use it. So they give you these little rhymes sometimes to help you remember. If p is low, the null must go. If p is high, the null will fly. Whatever. I think that's silly, but if that works for you, go for it. I'd much rather you just understand what it means. If the p-value is low, the p-value is a probability. So if I told you something and we could, it could magically calculate a probability of what I'm saying, and that probability was crazy low, you wouldn't believe me. You'd go, I don't accept what you're saying. I reject the thing that you're saying. I think the story you just told us is ridiculous. And look at this probability, 0.00001. That's pretty low, right? So then you would reject what I'm saying. That's what you do in a hypothesis test. If the p-value is super low, you're rejecting, then you're left to reject the only assumption that was made, which is your hypothesis test. Okay, and your alternative should be whatever's left over. If your null hypothesis is not true, then whatever the leftover is, that's your alternative hypothesis. That's how you should set these things up in general. Okay, so if the p-value is very high, then you just kind of go, it's like inconclusive. If the p-value is high, you go, well, it's plausible that it happened this way, but we don't actually have any evidence that it happened this way, but it's plausible. That's kind of what happens with a high p-value. And in that case, all right, I know there's a tendency to say, well, then, yeah, it proves the null. No, it doesn't really prove anything. It's all kind of inconclusive. It just says, well, statements you just made might be true, but it might be something different too. All we've shown is that it's plausible that, it could be correct. So It's real subtle with that language, but I will watch videos here in a couple of weeks where people tell me they've proven the null, and people tell me they're accepting the null, and then they'll interpret it that way, that we just proved this thing. But that shows a fundamental misunderstanding of hypothesis tests. It's not like a little error where, oh, I just made this one thing wrong. It's like the whole hypothesis test is invalid at that point. It doesn't do what you think it's doing. So just kind of focus on that. Try to make sure you're setting up your hypothesis tests correctly, because if you don't, it looks bad. Remember, the whole thing I'm looking for is how much did this person learn? Did they learn about hypothesis tests? And if you tell me that you've proven the null, I'm going to go, yeah, this person didn't learn hypothesis tests. They just learned how to punch some buttons in StatCrunch, right? Okay, we're going to come back to this lie detectors and the law discussion in a moment. I think we didn't talk about that last time, right? Let me know if I did, but I think that was my other stats class where we talked about lie detectors and the law. Was that that must have been yesterday? I don't think it was in here. I went back and checked the video from last time, and I didn't see us watching that. So we'll talk about that when we talk about the types of errors that can occur when you're running a hypothesis test, because a lot of times people just think of an error as, oh, a mistake has occurred. Well, we have to be careful about what we think of an error is in this kind of context. And then we have to recognize the type of errors that occur, because I think a lot of times people take an error and they just group all errors together. But the reality is all errors are not created equal, right? It's like the same thing when I'm grading your algebra test back if you took algebra and I'm grading a test in there. If someone just messed up a negative sign somewhere, I'm not going to take a lot of points off. But if it's clear they have no idea how to get through a problem, they're going to lose lots of points, right? So not all errors are created equal. They're not all treated equal. But that leads to a sort of a lazy way of thinking about errors. If we don't recognize the difference between types of errors, we'll just clump them all together and not really understanding the things that can go wrong with our situation, right? And we'll see that in our discussion about the lie detector test, right? Right. You don't have to worry about two-sided. Okay, decisions and conclusions. So there should be two levels of conclusions that you make for your hypothesis test. You should explain to me in the language of statistics what your conclusion for the hypothesis test is. That's just sort of wrapping up the problem. Your last steps where you decide if you're going to reject the null or fail to reject the null. That's your surface level, shallow understanding of or conclusion, right? Sort of shallow, not very informative. You're just basically telling me how you interpreted that hypothesis test at the end. That is not the important conclusion. There's two conclusions. The big one is the second one. So, but the first one, when you finish the problem, you're going to go into StatCrunch and you're going to have it run a hypothesis test for you. And then you're going to get a p-value out. And that p-value is either going to lead you to reject the null hypothesis or fail to reject the null hypothesis. I highly encourage you to use that wording. Students like to change to different types of wording, and it doesn't go well, basically. So, because then they'll start saying things like, well, isn't failing to reject the null hypothesis the same as accepting it? No. Isn't failing to reject the null hypothesis the same as proving it? No. Right? Again, just think of your hypothesis as some statement that someone is making to you, right? Just because someone tells you something and you're kind of like, I don't know. Just because you don't reject their statement doesn't mean you believe them either, right? You might just not have enough evidence to call them out and go, I know what you're saying is wrong because I know this, this, and this, and you're lying, right? In that case, you're full on rejecting their statement. But someone might say something to you that sounds kind of sketchy, but you don't really have any evidence to shoot them down. So you don't reject their statement. You don't call them out on their lie. But at the same time, in your heart, you don't really believe them either. You're like, I don't know, maybe they're telling the truth, but I kind of feel like they're not. That's different than believing them, right? So you're kind of in this middle zone. So that's what failing to reject the null hypothesis does. It leaves us in this zone where we can't really make any kind of useful conclusion, right? We can't really give evidence to anything if we fail to reject the null, because it could be that the original hypothesis is true, or it could be just that it's just believable enough that we can't reject it, but we don't really feel like it's the right thing. So failing to reject the null hypothesis is usually not good news, because it means you can't really use that hypothesis test as evidence in your argument, right? So because you're kind of in this zone where you're like, I don't know, it's plausible that the hypothesis is true, but it's also reasonable that it's not. I don't know. However, if we reject the null hypothesis, then it's very clear. No, we stand up and we are being counted as rejecting the null hypothesis. Well, if you reject the null hypothesis, then you have to accept the leftover, right? So that's your goal, is you make the thing you want to show is the alternative hypothesis, and then you're hoping that the way that p-value comes out, you get to reject the null. But again, you can't like just go through the motions and say, whatever the p-value is, I'm just going to reject it. You have to reject it on reasonable grounds, right? So generally what you're going to do is accept an alpha level. So just like when we were doing our confidence intervals, the three defaults, you would choose, I'm doing a 90% confidence interval, I'm doing a 95% confidence interval, or I'm doing a 99% confidence interval. You could do a 97 or a 93% confidence interval, but it's not typically done, and people would be like, well, why did you pick 93? Why is that better than 95? It sort of looks weird, and then people might wonder like, well, is that because it failed the 95% confidence interval, so you changed it a little bit so that you could make this statement? Like, it just doesn't look good. So you probably want to go with one of those three defaults, 95 being the main default, right? If you're not going to use a 95, and this is different if you become a statistician, but for now, if you're not going to use a 95% confidence interval, you should be able to explain why. Oh, well, the thing that we're studying is very safety related, so we want to be 99% sure because we don't want people to die from our work. Okay, that's a reasonable reason to use a 99% confidence interval, right? And you don't see 90% confidence intervals as much because no one wants to be wrong 1 out of 10 times, right? That's too much. If every time you say something to somebody, you're wrong 10% of the time, they're going to start to think you're not very good at stuff. So what you have to do is pick a cutoff ahead of time before you run your hypothesis test. If you wait till the end and you get your p-value and then you decide the cutoff, then you are biased by your own decisions. You are biased by what you want the outcome to be. So you have to, if you're going to do this ethically, you have to pick the cutoff before you hit compute on StatCrunch and know what your cutoff's going to be. But it's, again, there's the default of, we usually write these as the opposite. So a 90% confidence interval would correspond to a 0.1 alpha level in your hypothesis test, because 90%, the complement of that is 10%, and 10% gets written as 0.1, right? A 95% confidence interval has complement 5%, so that would be written as 0.05, just the decimal form of the complement of your level. 99% confidence level, that means the complement is 1%. 1% is 0.01. Did I say 0.1 a minute ago, or 0.01? Anyways, that's how we measure that. So usually for your problems, probably just stick with 0.05, right? Because then it's easily defensible. If I ask you, well, why did you end up using a 99, or why did you use 1% as the cutoff here? And you go, I don't know, I just picked a number. That's not really as good as an answer as if you go with the default of 0.05, right? And then as you get more comfortable with statistics, you can make more of your own choices, and you can make your own choice here for your cutoff, but you probably want to explain why, if you didn't use 0.05 as your hypothesis test cutoff. Just give me an indication as to why did you pick this other value. Because what you don't want to do is pick a value that makes the outcome the way you want it, right? Then all our credibility kind of gets shot, because we're sort of conducting the experiment to come out a certain way. And that's what you don't want in science. You don't want people saying, oh, we're going to design this experiment so we can make the case that cigarettes aren't addictive. We're going to design this structure so that we can make the case that oil consumption is not contributing to climate change. I mean, that's literally things that have happened and have the cigarettes cost people a lot of lives. The oil stuff costs people lives, a lot of money to try to fix climate change, and is sort of messing up the environment along with other stuff. But that's literally work that's been done where people set up statistics because they know if you work for the oil company and they have you run statistics, you're not going to run the report upstairs and say, hey, guys, guys and gals, look, it looks like we really are contributing to climate change. Because if you work for the oil company, that's not your job, is to do real stats. Your job is to do stats that make the company look good, right? So if you're trying to legitimately do statistics, you have to pick those values ahead of time, the p-value. You can't wait till the end and you're like, well, I don't know. I wanted to reject the null, but this number's not where I want. Right? Why don't I pick a different alpha level? That's it's not really genuine. That's being unethical in a statistical way, right? So pick that value for now. Just pick the default of 0.05 unless you have a good reason to pick something else. Okay, so there's a couple of methods that people use. You don't even have to worry about this. StatCrunch is going to do the number crunching for you. Confidence intervals can work as well. Sometimes, under certain circumstances, a confidence interval can be interpreted like a hypothesis test. Sometimes they're interchangeable. You can answer the same question either with a hypothesis test or a confidence interval. Sometimes they are not the same. So just watch out for that. Okay, wording your final conclusion. Remember I told you there was two conclusions? You're going to have the very shallow surface level conclusion where you tell me you either rejected the null hypothesis or you failed to reject the null hypothesis. But that's not your real conclusion. That's like a preliminary conclusion. So when you're trying to form your final conclusion, what you should be doing is putting things in the language of the original problem. Right? So think about it this way. No person, even people who are mathematicians and they spend their whole day doing statistics and stuff like that, no one wants to look at someone else's work, right? I mean, as people who aren't if you're not super into math, just think about that. Do you want to look at someone else's homework and their scratch work? Is that interesting to you? Well, it's not even interesting to math people either to sit there and look at someone else's scratch work. So your job when you run a statistical tool is to be able to make a conclusion that nobody needs to look at your statistics. No one needs to ask you a question, right? So the idea is you go into your boss. Your boss says, okay, here's some data that we have. I want you to go crunch some numbers, and you're going to come back and you're going to tell me, for quality control reasons, do we need to update our manufacturing software, or are we good how it is? And then you go and you look at the data, and you're either going to make a recommendation to your boss that, yes, we need to buy new machinery for quality control reasons, or no, we don't. Okay? What your boss doesn't want to hear is a day later you come in and you knock on the door and you say, I crunched the numbers and I decided to reject the null hypothesis. Your boss is going to look at you and go, what is that supposed to mean? What are you talking about? I don't understand. Am I supposed to buy new equipment, or am I not supposed to buy new equipment? That's what that person wants to hear. Your boss doesn't want to go, oh, you rejected the null? Well, give me your work and I'll read what the null hypothesis was, and then I'll piece all together what you're talking about. Your boss just wants you to come in and say, yes, buy new machinery. We need to. Quality control is these machines are breaking down. Our quality control, they're old. Quality control is getting bad, and we need new machinery so that we're getting nice, nice parts coming off the assembly line. Right? That's what they want to know. Do I buy new machinery or not? So think about when you give your final conclusion, think about it in the sense that you want to be able to make a statement to someone who has never taken statistics, doesn't know what you're talking about, but you can give them usable information, like going into your boss's office and saying, yes, my recommendation is that we buy new machinery for the manufacturing plant. Then your boss doesn't have to worry about p-values or hypothesis test or confidence intervals, but they know how to do their job. Oh, your recommendation is that we buy more machinery? That sucks, but okay, we'll buy new machinery. right? So you want two conclusions you should be giving me. One, explain to me how your hypothesis tests work. Did you end up rejecting the null or failing to reject the null? And then interpret that into words of the problem. So if your problem was about units that students are taking, or your problem was about hours worked per week for students, put it in that language. Make a statement that I can understand, that yes, we think that the mean number of hours that a student works during COVID is greater than 30 or whatever your conclusion was, right? In some kind of a way. Don't, if you finish up your part of the project by telling me, well, here's our p-value and that's below 0.05, so we rejected the null hypothesis, and then you stop, you're going to get that's a superficial conclusion. You're going to get a superficial grade, right? If you show me that you understand how to interpret that in terms of the problem, you're going to get a better grade. Okay, is how that works. So, and they say that here, right? And this I kind of want to just point out. Note that only one case leads to wording indicating that the sample data actually support the conclusion. That is another way of getting at what I've been talking about, which is the only way to support the conclusion is if you can reject the null, and then you have to turn to the alternative. You cannot show evidence for the null. You cannot prove the null, right? So don't. I know I'm going to get videos that say that, but I'm going to have to mark them down significantly because it shows that you don't understand this entire chapter. So just be careful about your language there. If you want to support some claim, state it in such a way that it becomes the alternative hypothesis, and then hope that the null hypothesis gets rejected. Okay? That's what you want to do. If you want to say, well, we think that under these conditions, the mean number of units that a student is taking during COVID is greater than 10, then that should become your alternative hypothesis, and then you really hope you get to reject the null, right? Now, the reality is you can play around with these hypothesis tests. I mean, it takes a fraction of an instant for StatCrunch to run these hypothesis tests, so you can kind of play around a little bit and see what the best way of communicating your content is, right? You get a little bit of leeway there. Caution, never conclude a hypothesis test with a statement of reject the null hypothesis or fail to reject the null hypothesis. Always make sense of the conclusion with a statement that uses simple, non-technical wording that addresses the original claim. So that's what I'm telling you is I'm fine with you telling me that you rejected the null hypothesis or failed to reject the null hypothesis, but if you stop there, you haven't really done anything. You then have to take that conclusion and put it in the words of your problem. You have to interpret that original statement to me. So I'm just trying to make it clear to everyone, that's where a lot of those points come from. Because the truth is everyone can memorize how to run a hypothesis test, but only some of you will actually understand what you're doing. That interpretation is the best way I have for me to figure out if you know what you're doing or not. So do that. And they even say in here, you never want to say accept the null hypothesis, because that's not what a hypothesis test does. It does not give support for the null. And hopefully you're starting to understand what that means, but some of you may not, because I get it. The way the probability and the logic works for hypothesis test is a little bit confusing. So it might seem like, well, I still feel like it gives evidence for the null. It doesn't. It just tells you the null is plausible, that it's a reasonable thing to think may have occurred, but we don't actually have evidence of it occurring. So we don't even use the word accept in your conclusion, because students accidentally say something like this, and this is like a heads up. Oh, they just said accept the null hypothesis. They don't understand hypothesis tests, and then for that part of your project, you're going to get a lower grade, right? It doesn't mean your whole project's going to be an F, but as far as hypothesis test part, I'm going to, okay, for the hypothesis test portion, this person gets a lowered score, right? And then maybe you hit a home run on your confidence interval, and then your grades up that, you're going to, one mistake in your project isn't going to sink you, but it can affect your grade significantly, right? Okay, let's see. Are we to the part I want to talk about? Oh, be careful with multiple negatives. These statements can get a little hard to understand, so just take your time. So, for example, there is not sufficient evidence to warrant rejection of the claim of no difference between 0.5 and the population proportion. It's confusing when you have 3 negatives inside of one sentence, so try to break it down if you can into a way that makes it a little more clear, right? If you can, but those can be confusing. Okay, types of errors. There are 2 types of errors, and I think a lot of times, non-technical people, when they hear that errors can occur in something, they just go, okay, well, sometimes it's right, sometimes it's wrong, and there's and some errors can occur, and we just sort of treat all the errors like they're the same, but that's not the case always. So what are 2 types of errors that can occur with a hypothesis test? Now, when we see error, it doesn't mean that the computer crunched the numbers wrong, and it doesn't mean that you did something wrong as the person conducting the test. Well, then who made the mistake? Well, no one made a mistake. When we say an error in this case, what we're talking about is the fact that, remember, there's always this unknown value. It's impossible for us to know. It's impossible for me to know the true proportion of Ventura College students who support the vaccine mandate. Because if we tried to ask every single student, we just wouldn't be able to do it. Some students wouldn't respond. We wouldn't be able to track certain people down. Some people leave. Some new people show up. So to think that at any given instant you can have the true value is usually impossible. So what we try to do is we use all these statistics to come up with our best understanding of what that proportion is. We want to try to give ourselves evidence of what the proportion is of students who support a vaccine mandate on campus, but we'll never really know if we're right or wrong, right? So these 2 types of errors can occur. 1, the mistake of rejecting the null hypothesis when it is actually true. So just like a hypothesis test is not magic, right? It's not like there's some magical force that's allowing the hypothesis test to magically know unknowable things. What the hypothesis test is doing is calculating a probability. Well, probabilities can go both ways, right? It's like, everyone was shocked when Clinton won, even though like 538 was saying she has an 80% chance of winning. That means 20% chance of losing. So even if a probability is pretty high, sometimes you end up in that zone where you get bit by the other complement of the probability. So there are times, if you do enough hypothesis tests, where everything will be done well, you're going to get a really low p-value and you reject the null, but in reality the null is true. Okay, well that's what happens when you play with probabilities. Sometimes you win, sometimes you lose. It's the same thing here. Sometimes we're going to be right, sometimes we're going to be wrong. But if we do things with a 95% confidence interval or level, that means we're going to be right about 19 times out of 20. That's pretty good. That's pretty good to be right 19 times out of 20 when it comes to things that are unknowable, right? That's why statisticians are, it's a good career to go into right now. You can make good money. You'll be valued at the company. You'll be useful because you can answer questions that other people don't know how to answer, and you'll be right, 95% of the time. You'll be right. So very useful. So that's one mistake, is that you reject the null when in reality you shouldn't. And you go, well, how do we fix that error? You don't ever know, because we don't get to magically know that we made the mistake. It's just that this one time your data is not going to come out right. It's just what happens. Type 2 error, the mistake of failing to reject the null hypothesis when in actuality the null hypothesis is false. Right? So we get a p-value that's too high. I get a p-value of 0.2. I go, well, that's bigger than 0.05, so I can't really reject the null hypothesis, but in reality, we should have. So why does this happen? Well, remember how there's that sampling drift, right? If I send each one of you out to ask 100 students what their opinion of the vaccine mandate is, you're all going to come back with different numbers. It doesn't mean that any of you did anything wrong. It means that there's just some drift in your samples. And someone could come back with kind of an extreme value. If you're all coming back with values around 0.8 and someone comes back with a value of 0.53, that's a long ways off. And we're going to, that's weird. Maybe that person didn't do anything wrong, right? That's what happens when you sample stuff, is that occasionally you're going to get very weird results. If you run a if that person who got the weird results runs a hypothesis test, they might come to the wrong conclusion, right? That's why it's helpful if we have everyone in the room do it. Then when yours comes out different than everyone else, you're like, oh, that's weird. These other 19 people all rejected the null, and I failed to reject the null. Well, guess what? You're probably that 5% error. Doesn't mean you did anything wrong, just that there's a 5% error. Okay, so you can sit down and figure out the types of errors. So for instance, let me kind of put this in perspective a little bit, back to the lie detector test. Right? I know, like in movies, they throw people in a lie detector, and you just think, why don't we always put lie detector tests on people? Why don't we take every person accused of a crime and make them take a lie detector test? Well, lie detector tests, despite what you've seen in the movies, not real reliable. Same with fingerprints. Fingerprinting is not nearly as reliable as people think it is. Right? We hear about someone, oh, they caught this person because of a fingerprint match. Well, rarely does that mean that they got like a perfect imprint of someone's thumb, and then they were able to exactly match it to, the individual who was the suspect. Usually what happens is there's like a little portion of your thumb, that little piece left an imprint, and they look at that little piece, and they call it, what do they call it? Points. Like they try to match a number of points between the partial fingerprint and your fingerprint, but it's by no means 100%. Right? It depends how much of a imprint you have, right? And there have been cases where people were convicted on full fingerprints, and then it turned out later that, no, we just have these two people with almost identical fingerprints or identical fingerprints. 8 billion people on the planet, you're going to get some pretty similar fingerprints. So both of those, even though we see it in shows and movies, actually not reliable at all. So, but it's not, the errors are not evenly distributed. So people will make the claim, and they say, no, actually lie detector tests are highly reliable, because if someone is guilty, they will fail the lie detector test 97% of the time, which is a problem, because first of all, that's a 3% error. Imagine if we're doing millions of tests, 3% means hundreds of thousands of people will be falsely imprisoned, right? So that's one argument, is no, actually 90% of the time, if someone's guilty, the lie detector will pick it up. But what is the other error? The other error would be if someone is not guilty, but the lie detector says they are. That happens much more often with a lie detector. So to sit here and say lie detectors are 97% accurate because if someone's guilty, we catch them 97% of the time, that's disingenuous, because that's only counting one type of error. The other type of error that happens way more frequently is that someone is not guilty, but they fail the lie detector test. So then we automatically go, well, you're guilty. You just failed the lie detector test. And then you go, well, what is that? Well, whenever it comes to these kind of processes, you have to think about what's being done. Is the lie detector a magic box that can determine like the truth of the universe? And they say, no, this person is telling a lie. No. What a lie detector does is most people, when they lie, some people have stuff going on that allows them to not do this. But your typical individual, when they lie, heartbeat goes up a little bit. They start to sweat a little bit. They get a little bit nervous. So that's what a lie detector does. Is it measures your level of nervousness. Well, if you're a person who hasn't committed a crime and you're picked up and taken down to the station and given a lie detector test, you might be a little nervous. You might be a little bit anxious, right? So it's very common for people to fail lie detector tests who are not guilty, right? This is why a lot of times you'll hear about like, well, this person that's a suspect decided not to take a lie detector test. And sometimes people are like, well, then they must be guilty if they weren't willing to take a lie detector test. No, what that person wanted was they don't want to take a lie detector test, fail it, and then have everyone assume, well, you're guilty because you failed the lie detector test, right? But you can't really understand that subtlety until you understand the types of errors that can occur with the lie detector test. If you can understand those, it's basically the same errors that occur with the hypothesis test, which is that you either reject the null and you shouldn't have, or you fail to reject the null and you should have. But again, you don't know this. You don't really know these outcomes, but they're going to happen one time out of 20 if you're operating at a 95% confidence level. Okay? With that, we will stop there. I'll leave Zoom open. Actually, I have office hours. So anyone who wants to talk to me in Zoom, feel free to do so. Enjoy your holiday. Make sure you're safe over the holiday and taking care of stuff. And then when we get back, things are going to move quickly, and we've got some important stuff going on. So take care of that. Okay, I'll talk to everyone later. Bye.